So far, we have managed to display a string, counter 0, and a plus button. And our button doesn't really do anything. Let's change that. Let's look at how we can handle events in reagents. Let's go ahead and add onClick handler to our increment button. And now let's think of how we can change our counter state. Let's go ahead and add onClick handler to our increment button. Reagent events are named using camel case. And event handler is a function, and this is where we will learn how to update our application state. Let's name our handler function handler increment and log to do for now. So now if you click on the button, we should see to do logged onto the console. So far so good. Now we have another problem. We have implemented the handler function, but we haven't solved our main problem, which is to update the application state. With the current implementation, it is impossible since ClojureScript values are immutable. In ClojureScript, once a value is created, it cannot be mutated. So how are we going to update our state? So we need to change the way how we approach state management. Enter atoms. Atoms are containers for state that change over time. Atom provides a way for you to manage state in ClojureScript. And it also enables you to model things that change over time. You can think of Atom as a reference type, for example, in other programming languages, such as objects. But the difference is that you can hold any value inside an atom. And all the values, as you know, are immutable. So you can hold values such as string, numbers, and even collections such as map or vectors. We can create an atom by calling atom function and passing initial value. Atom function returns an atom type. There are two ways to read the values out of an atom. First is the prefix notation. We can prefix add to an atom and then it will return the value that the atom is referencing. The second method is by using deref function. Deref function accepts an atom and it returns the value that is inside the atom. Personally, I prefer prefix style of getting the value out of the atom because it is more concise and more elegant way. Now let's look at how we can update the values in an atom. There are two ways to update the values inside an atom. So let's look at our first implementation, which is swap. Swap function takes two arguments, the atom and the function, to produce the next value of the atom. Swap calls the function with the old value of the atom and uses the value returned from the function as the new value of the atom. In our example, each call to swap will increment the value in the atom, giving us our counter value. Swap lets you march from one value of your atom to another. Reset accepts two arguments as well. The first is the atom like swap, but the second, instead of a function, reset accepts a value. And the reset function will take the value and it will use it as the new value of the atom. And this function can be useful in certain situations, which we will see very shortly. Now that we know what atoms is, how to read the value of atom, and how we can update the atom, let's implement our counter state. So first we need to change the counter state. Instead of using 0, we have to use atom and pass the value of 0. We also need to change our counter container. Instead of showing counter state, we will use the prefix notation in front of the counter state so that we can access the value out of the atom. And we also need to change our handle increment button. We will use the swap function that accepts our counter state, and then let's pass a function that increments the value. Now when we try to click the plus button, it does not work. The value in our atom gets updated, but our component does not get re-rendered. This is because our component doesn't keep track of the dereferenced atom values. This means that the reagent components does not automatically keep track of dereferenced atom values. So how are we going to solve this? Reagent provides its own version of Atom called Reagent Atom or Atom, allowing component to keep track of derefs. So what is a reagent atom? Reagent atom is like ClojureAtom, except it keeps tracks of dereferences. Reagent component that derefs any atoms are automatically re-rendered when their value gets updated. With reagent atoms, you can truly write reactive applications. So let's change our counter state to use the reagent atom, like so. And now let's save it and let's go back to our application, and our counter application works. Let's quickly also implement the decrease and reset functionality. We will add 2 buttons and then we will give them on-click handler. For decrement, we will use the swap function, which accepts the atom, and then we will, for the second argument, we will pass the decrement function, and for reset, we will use the reset function, which we looked earlier, and this time we will pass 0 as the second argument. So when you click on reset, the value always gets resetted to 0. So this is it. Now our application works. We can increment a number, we can decrement a number, as well as we can reset our number. In this video, you will learn the first on-click handler and how to write functions, handler functions. You also learn about atoms, what they are, how to create an atom, how to update an atom, how to get the values out of an atom. You also learn the difference between an atom and a reagent atom. And that's all for now, and I'll see you on the next video.